this problem is about finding all the zeros of the function f of x, x cubed plus 11x squared plus 20x minus 32 in an algebraic way, right? And they're supplying you with one piece of information, which is that f evaluated at -4 equals 0. So therefore, that that piece of information, that f of -4 equals 0, that means that when x equals -4, that will be a root of the equation, right? Because the whole f of x will be 0 at that point. 2, we can use long division or syncretic division using that specific new factor. So the x equals -4 can be turned into a factor. And we can use it to do long division or syncretic division. If we use it as a factor, we can use it as in long division. If we use it in syncretic division, we can use it as a solution. And then just finish the factoring. So after being able to do syncretic division or long division, we're gonna have one less degree polynomial. So if we start with a cubic one, we're gonna end up with a squared one, and that could be solved. That could be solved. Not necessarily saying that it can be solved. It could be solved. So to figure that out, let's start with long division first. So log division is x cubed plus 11x squared plus 20x minus 32. We put that inside of the box. And then we put the factor as x plus 4, which that's the factor meter of x equals -4. And we proceed to do the algorithm to do the long division, right? So the process goes like this. You look at the first term inside of the box, and you find a factor that you multiply times the first term in the factor outside to get the x cubed. So that will be x squared, right? So x squared times x gives you x cubed. Now, after you do that first process, you do the multiplication again, but then you subtract it. You change the sign, and you put it right in the bottom of the x cubed. And then you continue doing that process with all the terms inside of the factor. So you do it with the 4, so 4x squared, but then you change the sign again, so -4x squared. And then you stop there for a moment. You simplify what you can, so cancel x cubed with the negative x cubed. Then 11x squared minus 4x squared. That turns into 7x squared. And then you lower down, you bring down the remaining balance, so plus 20x minus 32. And then you repeat the process again. So tell me, what variable or what number or what factor should I multiply by x to get 7x squared? So it turns out if I multiply by 7x, that gives me 7x squared. And then I repeat the whole process again. Multiply by 7x squared times x, 7x squared. Multiply times the negative, that gives me -7x squared. 4 times 7x gives me a positive 28x. But then I multiply times the negative, so that gives me -28x. I take the difference, cancel all the 7x squares, and then I have a remaining balance of -8x minus 32. Then I repeat the process again. What number I can multiply times x to get -8x? So that would be -8. And then I change the sign, so it'll be plus 8x. And then I multiply 4 times 8, that'll be -32. Change the sign, positive 32. Turns out everything ends up canceling out perfectly. There's no remainder. So the solution to the factoring would then be the factor x plus 4 times the new factor on the numerator, sorry, not the numerator, but on the top, which is x squared plus 7x minus 8. And that's how you built up the factor form by just taking out the x plus 4 factor. Now, if you continue, you can break down the x squared plus 7x minus 8 by playing out with numbers, which I'm not going to be showing how to do here. But if you play out with the numbers, basically you need 2 x's in the first term. You need 2 numbers that multiply to give you 8. And then you choose the sign such that it gives you plus 7x. And all that ends up with the solutions x equals -4, x equals 1, x equals -8. All right, so for the second part, synthetic division is actually a little bit of a different process, less than algebraic. Is more like numerical. So here we go. We basically end up creating a table where we put the coefficients starting from highest power to lowest power. So if there's no such coefficient for a power that's supposed to be there, we put 0 for that. But in this case, that is not the case. So we start with 1 for x cubed, 11 for x squared, 20 for x, and negative 32 for x to the 0 power. Then we go ahead and by default, we put a 0 right below the 1. We add the 1 to the 0, and we end up with the 1. We write down the factor on the left side, which is x equals negative 4. And we are going to be repeating the process of multiplying that negative 4 times every single number in the bottom. So we start with a 1. So negative 4 times 1 gives you negative 4. And then you write it down below the next number, 11. And you do the difference. So 11 minus 4, that gives you positive 7. Then you do negative 4 times positive 7, that gives you negative 28. Plus 20, that gives you negative 8. Negative 4 times negative 8 gives you positive 32. Plus minus 32, that gives you 0. So the ideal thing is that you get a 0 reminder in that box after doing all that process. And after you're done with all that process, then you can ensure that x plus 4 is a solution to the root. And we already knew. So basically, we already knew that doing all this process is going to give us 0 in the box right there. But all we really needed were the coefficients right below the line, which is 1, 7, and negative 8, so that we can assign them to a new equation of second degree, right? Which is x squared plus 7x minus 8. And now we break those just the same way we break them in the long division problem, by playing around with numbers and factors, and then ending up with the same roots, basically. X equals negative 4, x equals 1, x equals negative 8 are all the zeros. All right. I hope this was really helpful for you guys. Thank you for watching.